What if I told you scientists just found the smallest black hole ever discovered, and it shouldn't even exist? Meet G3425, a mysterious binary system hiding the smallest black hole we've ever detected. Located about 5,800 light-years from Earth, this system contains a massive red giant star, and something else. Something invisible. Something tiny. Something that's breaking all the rules of black hole physics. For decades, scientists thought black holes this small couldn't form. But G3425 just proved them wrong. And this discovery? It could change everything we know about how stars die, and what's really lurking in our galaxy. Stick around, because this smallest black hole is about to blow your mind. Section 1. What is G3425? So what exactly is G3425? It's a binary star system, two objects orbiting each other in space. One is easy to see. A red giant star about 2.7 times the mass of our Sun. But the other? You can't see it at all. That invisible companion is a black hole, and it's tiny. We're talking just 3.6 times the mass of the Sun. Now, that might still sound huge, and it is. But in black hole terms? This is a runt. Most black holes we've found are at least 5 times the Sun's mass, sometimes way bigger. This smallest black hole sits in what scientists call the mass gap, a mysterious range between 3 to 5 solar masses where black holes were thought to be super rare, or maybe even impossible. Think of it like this. Imagine you've always believed elephants only weigh between 10 and 20 tons. Then suddenly, you find one that's just 3 tons. It doesn't make sense, right? But there it is. That's G3425. A cosmic rule breaker. Section 2. How did they find it? The clever method. Here's the crazy part. We can't see black holes directly. They don't emit light. They don't glow. They're literally invisible. So how did scientists even know this smallest black hole was there? They used a brilliant detective trick. Instead of looking for X-rays or bright flashes, the usual black hole giveaways, they watched how the red giant star was moving. Picture this. You're watching a dance, but you can only see one dancer. The other is invisible. But by tracking the visible dancer's movements, their steps, their spins, their wobbles, you can figure out there's an invisible partner pulling the strings. That's exactly what happened with G3425. Using data from two powerful tools, the LAMOST telescope and the Gaia satellite, scientists noticed the red giant was moving in a weird way. It was wobbling. Orbiting something massive. Something invisible. By mapping those motions, they calculated the hidden object's mass, and boom, 3.6 solar masses. A black hole. The smallest black hole ever found. No X-rays. No bright accretion disks. Just pure gravitational detective work. This method is a game changer. It means we can now hunt for dormant black holes, the ones that aren't actively eating matter and lighting up the sky. And trust me, there are probably hundreds, maybe thousands of these hidden black holes scattered across the Milky Way. Section 3. The orbit mystery. Why this black hole is weird. But wait, G3425 gets even stranger. This smallest black hole isn't just breaking records with its size. Its orbit is throwing scientists for a loop too. The black hole and the red giant are in what's called a wide, circular orbit. They're far apart from each other, and their path around one another is almost perfectly round. Now, that's odd. Here's why. When a massive star explodes into a black hole, a supernova, you'd expect chaos. A lot of material gets blasted off in one direction. That kind of violent explosion usually makes the orbit elliptical, stretched out, like an oval. But not here. G3425's orbit is smooth, circular, almost like nothing dramatic ever happened. It's like expecting to see a bumpy, crooked road after an earthquake, but instead, you find a perfectly smooth highway. Scientists are scratching their heads. How could such a smooth orbit form after something as violent as a supernova? This is forcing astronomers to rethink their theories about how binary systems evolve and how black holes form. Maybe the explosion wasn't as violent as we thought. Maybe the star collapsed more gently. Or maybe, we're missing something fundamental about how these systems work. Either way, G3425 is making scientists question decades of assumptions. Section 4. Why this discovery matters, the big picture. So what does this smallest black hole really mean for science? A lot. For years, astronomers believed black holes in the 3 to 5 solar mass range were either super rare or just didn't exist. The thinking was, if a star was too small, it wouldn't have enough mass to collapse into a black hole. If it was too big, it'd form a massive one. But G3425 is changing that. Thanks to new technology like Gaia and LAMOST, we're able to detect black holes without relying on X-rays. This opens up a whole new way to hunt for these elusive objects. In fact, scientists now believe there could be hundreds, if not thousands, of low-mass black holes hidden across the Milky Way, just waiting to be discovered. G3425 is proof that our methods for finding black holes are evolving. And we're just scratching the surface of what's out there. On a cosmic scale, this smallest black hole isn't just another discovery. It's reshaping how we think about stellar evolution and supernova explosions. By studying G3425, scientists now have new data to test their theories about how stars live, die, and what they leave behind. This discovery doesn't just fill in one gap. It opens up new questions about the life cycles of stars, and the hidden black hole population in our galaxy. Section 5. The Chihuahua oxygen monofluoride black holes. Fun analogy plus scale. Let's put this in perspective. G3425 is like the Chihuahua of black holes. Small? Yep. But still capable of packing a punch. Sure, it's not going to devour galaxies or bend light from across the universe like its supermassive cousins. But don't let its size fool you. Even a small black hole like this has an immense gravitational pull. It's powerful enough to warp space and time around it. So while it may be the runt of the cosmic litter, it's still something you wouldn't want to get too close to. And who knows? Maybe one day we'll find an even smaller one and call it the teacup black hole. Just imagine explaining that to your friends. Conclusion and M. Call to action: the discovery of G3425, the smallest black hole ever detected, is more than just a cool space fact. It's a reminder that the universe is full of surprises. That even when we think we've figured things out, space finds a way to throw us a curveball. This tiny black hole is challenging old theories, opening new doors for detection, and hinting at a hidden population of black holes we never knew existed. And the best part? We're just getting started. If you found this mind-blowing, smash that like button, subscribe, and hit the notification bell so you don't miss our next deep dive into the cosmos. Got a topic you want us to cover? Drop it in the comments below. Thanks for being part of Cosmic Knowledge. Keep looking up.
If you enjoyed this video, please like, subscribe to Palsa Lab, and turn on notifications so you don't miss our latest uploads. At Palsa Lab, we explore space, science, astronomy, AI, and emerging tech. bringing clear explanations and fascinating discoveries. Have a question or idea? Drop it in the comments. Stay curious, keep exploring, and thanks for watching. See you next time.